Yep, it's recording. So let me just make sure, real quick check, because that determines how many breakout groups I need. If we have a small number of people, then we may only need one. Let's see. Being recorded. We're expecting an else. Yeah. And I did put links in the Google group to the notes pages that we'll need for today, other artifacts. Great. Sounds good. Let's see. Let's make sure. Just a minute. Okay, we'll get started momentarily. So.
Oh, the shares correctly. You have to look past the hype. I think there's something interesting in because what that might let you do is in small cases prove that you ran the code and got a certain result.
He just wanted to put it on one of the cheats.
Oh, okay.
Yeah.
Well, if it's like IPFS, this is like
All right, we can go ahead and I think we can go ahead and get started
later.
All right, everyone online can hear. Everyone can hear me in here, of course. So I think we can go ahead and get started. Well, welcome to our final and afternoon session of ACM Rep. This tutorial that we're going to do is a couple different interactive exercises. We're calling this software quality practices for reproducibility. As materials co-developed by myself and my colleague Miranda Mundt. We're both very interested in researching how people develop software, how we can help them develop it better. And we signed up to actually give multiple tutorials. We're giving a tutorial here, which is like a trial run of some of the content. And then we're gonna have to do an even bigger version of it with even more preparation for a different conference. So thank you for being our guinea pigs in test running some of this content. And I hope you'll be forgiving or any of its shortcomings, which would be fun.
I think we're seeing presentation mode.
That's gonna happen. Are we?
Yeah.
Yep. Try this. That better?
Yeah.
Yeah.
Oh, interesting. I want to do it like that. In any case, so the objectives of the tutorial overall, first is to cultivate a deeper understanding of how the principles of software quality engineering can be applied to help us create more robust, more reproducible software, figuring out how there are many different ways in which we can tackle the question of reproducibility. We've looked at many different angles of this problem, views of this problem throughout the conference. And the view that we're looking at today is one of engineering the software itself to be more robust, more capable, less prone to error, easier to get reproducible results from, right? And then the second part is to identify software development practices and processes that align with the reproducibility objectives that you may have or that the teams you work with may have. And finally, you'll be learning how to facilitate software process improvement on projects. We'll go through some of the material on how we do facilitate software process improvement and look at that with reproducibility in mind. So our schedule for today, first half of this is looking. I'll be giving a little bit of an overview presentation, and then we'll be doing some exercises and some discussion, as a group. I think we can just have one group here. And then we'll take a break. And then the second half of it is on software process improvement and techniques for that. So with that in mind, we can go ahead and get started. We'll talk a little bit about about software quality, about reproducibility, how these things align or may align with software practice, right? And how we can build, more robust software, stronger teams, better, we work together better, get more reproducible software, right? That's the idea. So for a little bit of background for myself and Miranda, who contributed to this material. Yep, we're good. So as researchers from Sandia National Labs, we work with a lot of different scientific software teams across many different domains, right? And what we're interested in is in advancing both the study and the practice of software engineering in the domains of science and engineering. And with that in mind, our real goal, and it's really its quest for quality. How do we get better software, right? So we seek to model, understand, and predict the factors that lead to high quality software systems. Well, when we say quality, right, there's a couple different definitions you'll find out there. There's the IEEE definition that some people may be familiar with, which is the degree to which a system can meet specified requirements that are set out, or the degree to which that system meets customer or user needs or expectations. And then there's the ISO IEC definition. That's the one we'll be using, and I'll explain why, which is just quality. The quality of a system is the degree to which that system can satisfy the stated and implied needs of all its various stakeholders, and thus provide value to those stakeholders. So when we talk about scientific software, Miranda and I, prefer the ISO IEC definition of quality. Because one, scientific software rarely has formal requirements. Like, it's not like you're building a banking application where you know what the end product's going to look like, right? No, you're building a piece of scientific software to explore questions that you don't even know the answers to, right? So it's oftentimes the case that you don't really have formal requirements set down that are agreed upon in advance, as you would say with a banking application, right? The other part of it is that scientific software developers are often their own users. They are often part of a community of people that may be using that software. So we really need to be thinking more holistically about our stakeholder model, right? So when we bring like a software engineering perspective to that, that's kind of what we mean when we talk about quality. So quality in software engineering parlance has many different dimensions, or as we say, ilities, right? So the idea of a software quality model, and we're going to be using the ISO IEC model when we kind of talk about quality today, is that quality is defined by some set of characteristics with relationships between those characteristics, and we have a framework for specifying quality requirements and evaluating that quality. So that spans everything from, say, functional suitability, like correctness, like feature completeness, right, to aspects of usability, right? So learnability, operability, user error protection, and then other things like portability or maintainability, right? And the idea is that there's no like one single metric, one single approach, one single anything for quality, but rather it depends on a case-by-case basis for what different projects are aiming to achieve, right? So when we talk about theory, in my mind, when I say this, I'm thinking really in terms of the theory of software quality construction. So from a theoretical perspective, when I'm talking about quality, what I mean is that there are objectives that stakeholders have, right? And then based on those objectives, they define certain quality characteristics, like we need our software to run on these different HPCs, so it needs to be portable to those different HPCs. So those are quality goals. And then they set strategies in how they work and what they do in order to realize that quality through their practices, processes, tools, designs, right? And so there's a direct connection in my mind when I talk about quality and practice, the things people are doing, right? So what that all means, when we look at a software engineering view of quality, is one, is that teams, like I said, the presentation yesterday, the teams invest in software quality strategically, right? Quality is not an absolute good. You want portability, right? But you don't need to be portable to all machines until the end of time, past, present, and future, right? No, rather you set limits. You say, I want to support these operating systems, these GPUs. I'm not going to commit to supporting everyone's platform, right? So the idea is that you're looking to maximize certain aspects of quality, but you also have to balance it against other needs. How much time do you spend on ensuring that quality versus other things that are equally important, like, I don't know, implementing the algorithms to actually do the science, right? These are all trade-offs that we have to make. The next part is that quality is something that we can and should address throughout the software lifecycle, right? So if we want to have quality in our end product, we have to be thinking about it during requirements, during design, during implementation. Reproducibility is no exception. And that's kind of the view we're going to be taking today. And then finally, based on that, what we're saying is that each stage of that work, there may be practices, processes, tools, approaches that could help us achieve those quality objectives. So we need to be thinking about what can we be doing to ensure reproducibility, each step of the way, right? So when we talk about reproducibility, generally we'll be using the ACM definitions, right? And I float back and forth between different definitions of reproducibility. In the ACM definition, that's specifically when you have your software, you give it to a different team, or like there's a different experimental setup, right? And you expect to get the same results. They make a distinction between repeatability, reproducibility, and replicability, which is good. And at the same time, I kind of interchangeably, when I use that word, I interchangeably use that with the nascent definition, so you'll have to forgive me. But it's the idea, it's the ability of anyone, you, your users, other people, to obtain consistent results from the software. Given the same inputs, you have the same code, we should get the same results, right? Under the same conditions of analysis, right? That's what I generally mean by reproducibility, though I also kind of mean within that also repeatability, reproducibility, replicability, right? And when we look at reproducibility as an aspect of software quality, like I mentioned in my talk yesterday, right? That can help us to surface, to identify different goals we may have with our software, right? So if you say that we need to make it easy for different people to get those consistent results from the software, right? So if I hand you my software that you're able to use it, well, then that's usability, right? We would want things like it should be easy to learn how to use the tool. It should be easy to, to pass in the arguments that you want to use. And there should be code in there that actually prevents them from making, subtle mistakes that would affect the end results, right? They should know what they're doing and it should protect them from error, right? In the same way that if we want, if there are issues with reproducibility that we can fix them easily, that's a maintainability issue, right? We can be looking at, well, how are we structuring the code? We can think about, is it easy to analyze? Are we writing code that is testable? Are we defining tests around that code to protect the behaviors we want to protect against unwanted change? And then if we're looking at, reproducibility over time, right? Can the code survive? Because everything around it is changing. The hardware is changing, the libraries it depends on may be changing, everything around it, right? Then that's other things too. That's compatibility, that's portability. And these are things like reproducibility seems like a big daunting challenge, because like consistent for how long, in how many situations, to what degree, right? But we can control things like usability. We can control things like maintainability. We can implement software that is better at these things. And the goal is, or should be, to develop software that's going to be more survivable, that's going to endure, that's going to be more sustainable, right? That's really what we're after. So taking all of that together, when we look at reproducibility from a software engineering point of view, right? When I say that, I am encoding certain assumptions, certain hypotheses that do need to be tested. I'm not saying that I have all the answers, right? But when I, as a professional, say these words, right? There's a bunch of different assumptions that are in my head, right? And among those assumptions, there are a couple here that I've written out. One is that reproducibility is not an absolute good. There's no such thing as an absolute good in quality, right? It's only quality insofar as it helps you meet your objectives. So you're not promising reproducibility for all time, for all users, on all platforms, in all use cases, right? But rather you are defining, you're saying, I'm going to support and invest in reproducibility this much, right? Because that is what I need to achieve my scientific objectives and advance the state of the art, right? But it's not an unlimited commitment. And I think it's a much healthier way of looking at it, right? Because when I talk to teams, we do a lot of consulting with teams, right? And if I ask them why their code isn't more portable, they'll say, well, we can't afford to support Windows right now. It's hard enough getting it to work in Linux. And that's fine. But if I ask them, why isn't your code more reproducible? I'm insulting your academic integrity, right? And I want to move past that. It's okay that it's not eternally perfectly reproducible, right? That has never been the goal, right? The other part of that, there is sort of a hypothesis here that high quality software is more likely to be reproducible and to remain reproducible than low quality software. right? So the bigger it is, the more complex it is. If you have a big complex climate simulation, for example, right? Will argue that quality in that product and each of its components directly determines the degree to which that thing will remain reproducible, right? Because quality ultimately means that you have control over the behavior of your software. And the behavior of your software is what gives us reproducibility, that the behavior is consistent, right? And with that in mind, reproducibility probably aligns with some quality goals, but it may compete with others or be in conflict with them, right? We often know, for example, that performance works against most other aspects of quality. The desire to make everything fast sometimes is either orthogonal to or in conflict with most everything else. That's just an example, right? But there's also other other ways in which reproducibility may conflict with other things. So look at portability or compatibility. So with compatibility, what we're saying is we want our code to work with many different libraries, in many different software environments, right? But as a result, the more we commit to doing, the more we say we prioritize compatibility, the more work we're making for ourselves for reproducibility. Because I now need to make sure I'm reproducible when working with this library or with this environment. Same with portability. If you support 5 different platforms, now you're saying I'm going to be reproducible in 5 different environments, right? So the more you say I'm going to prioritize portability, you are also potentially increasing your commitment to reproducibility. You may be, right? So these are things that we need to be cognizant of, right? And then, like I said, reproducibility can and should. We should be thinking about this across the software lifecycle. We should be thinking about design, for example, all the way back, right? How do we structure the software in ways that make it more manageable, easier to add features, easier to confirm behavior, right? All of these things come into play. And then finally, and that's kind of what we're looking at today, is we're looking at, are there software engineering tools and practices that could help ensure that reproducibility? So from the perspective of our team, we do a lot of work with different scientific software teams, right? And what we've realized is you can't expect a team that just has a small prototype research code to adopt every single imaginable practice tool, full continuous integration testing and continuous deployment and full documentation and a user support process. That can't happen overnight, right? But the idea that what we found in our work is that we try to stage this. So we say, if they're a certain stage of maturity, we'll focus on the bare minimum, right? If they're very early on in the development process, we're not expecting them to do everything, but amongst various things, we say they should have version control. They should be using that, right? That used to not be the case. Well, I used to know a lot of teams that didn't even know what version control was, right? We're much better on that point now. But, and then as we move on, well, okay, what are we doing about testing? What are we doing about documentation? Do you have a process by which you're doing your code reviews, a process by which you're managing your requirements for your software, right? And we build up to that. And the question that comes up in this context with reproducibility is, which practices? If they just said, I only want to focus on things that are going to help me with my scientific objectives. Either my time to science is faster, or my results are better, or they're more reproducible, right? Which things can we tell them to do? Like, what would we recommend that they do, right? There are some things that we can think of that we've kind of crafted, right, as a community, like using containers, containerization, so if you can package the software, right? That's an example of something that we can do. But what about, testing? What about testing? What about documentation? Are there things in there that make the software more interpretable, more explainable, more manageable in some way that helps reproducibility, right? And that's kind of where we're going with this. So to answer these questions, we have Miranda and I have a lot of ongoing case study work. Like I mentioned in a talk yesterday, we have been working with many different teams in many different contexts saying, okay, what works for you? What doesn't work for you, right? What helps with reproducibility? What doesn't? And in general, they tend to give, a variety of answers, but a lot of them are in agreement on the basics, right? Some things like there has to be version control. There's no way for us to do that reproducibility at all if we're not doing that. That's good. I'm glad we're all doing that, right? But there's other things as well. So when they talk about testing, they say, okay, when I'm writing tests for reproducibility, they might look different than tests that weren't really focused on that, right? Maybe I'm writing special tests to probe certain properties or behaviors of my algorithm.
under different conditions to confirm that it doesn't diverge in weird places, or I can just guarantee that it's going to behave consistently, across the whole parameter space, for example. Documentation is another, right? Part of the, we talk about reproducibility. When someone else is trying to reproduce your code, right, your results, they have to understand your mental model, how your software is supposed to work, how they're supposed to interact with it, right? And you can communicate that both through user interface, but also just through things like documentation, right? Other examples that come up are things like code reviews, issue tracking. There's a big push among the teams that we've talked to, right, for things like transparency. They say, we want to do everything in the open, right? We want to have a public record of our design decisions, of how we're handling bugs, what features we do and do not support, right? That they believe that all of these things collectively are helping them to ensure that their code is of high quality and that it behaves consistently, right? And that these are all examples, right? But what I'd like for us to do as an exercise, I'll share this. I think we have we have enough for just one, we can all do one group here, right? So what we're gonna do is we have 3 stories. All of these are based on real life examples that we've encountered and had to deal with, right? And that deal with different aspects of software quality, and that ultimately, in certain ways, may deal with aspects of reproducibility, right? So what we're gonna do, I'll put the link in the chat. So I don't know who's logged into the Zoom. Let's see, or how I'll get this to you. I shared it in the chat, but for others who are, actually we have enough for 2. I think we have 1, 2, 3, 4. How many people do we have here? Casper's not on right now.
I don't know.
Huh?
In the meeting?
Yeah, in the meeting in total. Just everyone here. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. What I think we'll do is we're going to do 2 breakout groups. I think we have enough people for that. So for those who are online, if you go to the, you should be able to open this Google Drive. If you go to breakout group 2 and open that, you'll be taking notes there. And for the people that are here in person, it will be breakout group 1. There's a folder there for stories. And what we're going to do is we're going to pick, there are 3 stories there. I think we can get through at least 2 here today. Each team can spend like 10 minutes with each story. We'll choose one person to read the story. You'll choose one person to read the story and lead the discussion, another to take notes on the questions that are in the notes page and other reflections you may have. And then we'll spend 10 minutes recapping on that. How does that sound? And does anyone have any questions?
So is each group, okay, never mind. I answered my own question.
Y'all are a group, and we got some people online who can also be a group. What I'm going to do is, does everyone online understand? Hopefully.
Yes, we are with you. Yeah.
Oh, fantastic. So I'm going to mute you over here so they can't hear you. You can't hear them. That way you're not talking over each other. How's that sound? And I'll check in with you all here in a moment.
You also done the breakout.
Hi, Red. I'm not getting what do you mean by constellation? Is it related to the code itself, like
Okay, we're coming back together here in just a second. I guess I'm gonna grab something. I know Mesna had to step out for a second. We'll get started here in about a minute or two for the next part of this. But yes, the question that came up here on this group, on the in-person group, was we're talking a lot about feelings, and I thought we were talking about software, right? We're talking reproducibility. We're talking about mechanical things. There are no feelings involved, right? I wish that were so. I wish that were the case, but it is not. In reality, we have to meet a lot of our work in software engineering research. Welcome back. A lot of our work in software engineering research is dealing with the human. What can we do to empower people to do better, get better results with their software, to do better work with their software? And oftentimes that ends up involving a lot of these human elements, not just the technical ones. A lot of my PhD research actually was in formal verification and theorem proving, proving that systems can't break or fail, or what have you, or will obey certain properties, and constructing elaborate systems for constraint satisfaction, other problems like that. But what I realized is you can build the perfect tool, but it doesn't matter if no one's going to use it. And the buildings people are going to use, you have to understand them. And that, of course, is why I'm a therapist now at Sandia. That's where my life has led me. But so I think we'll start with our folks online. Just wanted to get a sense for your reactions to the stories, how you felt about them, what came up in your discussion.
Yes, I think it's related to the way that how I usually do the coding. So if I'm the kind of person that usually use documentation and put notes and between the lines in the code, it will be easy for me to accept the thing that will be a bit changed. But if I'm kind of person that just coding for coding, it will be, I will be not accept, and it will be difficult for me.
Right, that makes sense.
So as for example, during our undergraduate, we say usually, do we clean code? Do we have a clean code or dirty code? So if I'm doing clean code with notes, no, it's fine for me to accept any update or someone ask me, or he going to change or I'm going to change. But by doing dirty code without function, an obvious name for the functions or obvious name for the parameters or the variables, no, it will be difficult. I will not be accepted.
Right. Yeah, but oftentimes with scientific computing, we're often writing quick and dirty solutions more often than we'd like to admit. You know what I mean? So there's a tension there. There's a tension there between wanting quality and the time to science, right? That teams have to navigate. So for folks that are on the, here in person, what were your thoughts on the stories you read? Any highlights, anything you'd like to speak to?
I think you teased what we were talking about a bit, but the feelings, how those are, yeah. We've related to some of the pitfalls that some of the people in the stories were. I had that experience being like, yeah, I could explain this code a year from now, but couldn't.
Makes sense. So just to summarize, to tell you a little bit about the outcomes of each of these stories. So David ended up training up another person on the team on C++ software design so that he wouldn't be solely responsible for all the breaking changes, and the whole world was just on his shoulders for so long, right? And then they got to a healthier place because they kind of agreed that, well, we need to focus on how we're doing this design, and that motivated a lot of meetings on how we do it better, like kind of redesign this, make it better, and helping other people to take the lead on that kind of work, right? So that's now more egalitarian that way. In Pam's case, they eventually had a coming to Jesus moment. They said, we can't live like this anymore. Our code has no documentation. We keep having to onboard people and it's just not working. And we have to, like, it takes hours out of my day to explain how to run the code to this undergraduate student because there's nothing written down anywhere, right? And Pam was able to get them to actually commit to documenting the code. And everyone was happier as a result, right? And of course, in Ella's case, they ended up, it completely changed the course. Finding the bug, that the bug happened in real life, completely changed the course of the project because something that they thought wasn't even physically possible was possible, right? And now everything became a question about what they thought was the bug. They said, okay, I want you to simulate that. I want you to simulate what you thought was a bug. Now that we know that it's real, you need to focus on building capabilities to better probe that behavior, right? So it's sort of difficult to predict where the software is going to lead you, right? But all of these practices also, and part of the reason why I wanted to bring them up here, is that all of them in certain ways relate to reproducibility as well, right? Directly or indirectly. Like compatibility, breaking changes, right? Altering the consistency of the behavior, that can affect reproducibility. Documentation can affect the usability of code. Other people can't use it. If other people don't know what your code does or how to use it, then there's no way for them to actually get the results that you got, right? And then finally, testing, right? We want to write good tests so that we can control for the behavior of the software, but the intended behavior of the software, of course, is a moving target, right? And that's something that we're constantly having to deal with. So what I'd like to do now, for this latter part, so the next thing we have here, and this is just a small self-assessment, and then I think we'll be going for like 20 minutes, is I'm gonna put this link in the chat. There is a small self-assessment. Make sure that it works. I can click on it, I believe. There's a password. Hold on. There shouldn't be a password. Oh, well, unless it's on. Hold on. No, yeah. So settings. We'll just make it public. There you go. Now, if you refresh, if you access that link that I just put in the chat, where you type this in or scan the QR code, there's a small self-assessment, and this relates to, if you can think of a project that you're working on or that you're interested in. If you can't think of anything, that's fine. You can still contribute to this discussion. But if you want to fill this out, what aspects of software quality are important to your project? What do you do or try to do that you think might help with reproducibility? Like, could be anything from containerization to writing good tests or what have you. And then what practices would you like to improve, if you could improve or do better on as a researcher, right, as a developer? Because that's going to be the focus of the latter portion of our tutorial, is on software process improvement techniques. Make sense? A few minutes just to gather the thoughts.
Hey. Don't have a little self-assessment, then we're gonna have a discussion.
Yeah, you can't stop this. You just got.
Oh, good. It gives us a few minutes to gather those thoughts before we have a little bit of a discussion. Oh. I got a paper accepted. Yay, three accepts, one strong accept. Three to the top. Sorry, I'm just like excited.
Conference.
Oh, this is for USRSC.
Oh, nice. I'm waiting to hear back on a poster from them that you know about.
Yes, I'm actually I'm the co-chair for the posters. So I can't weigh in yet.
Okay.
I'm also not, I won't be judging you or reviewing you. Other people are doing that. My job is to sign off on the reviews.
Okay.
I'll let you know once they.
Yeah, once they've dropped. I'm surprised there's not more overlap between this conference and the RSE conference, the Research Software Engineers.
I think part of it is just that, I will say, I think part of it is that for the next one, we need to do more advertising. I heard that a number of people were saying, oh, I wanted to attend, but I only knew about it like 1 week in advance, you know, which is nice for as much as we advertise, we got like 50 people, which is a really nice, like 47-ish people, right? I think it was a really good turnout. In terms of people.
Person or?
Google group, like what, 47 people? They were like.
No, it was more than that. That's what I'm thinking. I think we had 58 altogether.
58 altogether. That's not bad.
Yeah, I can't remember and it was like 40, closer to 47 There are 243 in person, or no, 35 in person or something like that. So yeah, it wasn't bad. I mean, I don't think the Google Groups as I don't think it got updated on like the last couple days. We just kind of lost momentum in doing that. So everybody got added that was there. So got added to the Google group, but not necessarily to everything.
So I will celebrate later. I think I got multiple papers. Sorry, I got multiple papers accepted. Okay, so I'll celebrate later. But first, let's see about responses. So I think we're ready here. I can see where people have already filled things out. So what I'd like to do now is kind of go around the room and think about people's answers. Each person would like to go over the answers, the answers that they gave. I'll share answers what we've got here on the screen. We'll start with people here in person, and then we can go online. How's that sound? These are all responses we got. Overall, top concern among people who've filled out the survey so far, usability, followed by performance, and functional suitability, so correctness, feature completeness, all of that, but also maintainability, reliability, and portability to varying degrees. So if each person wants to talk a little bit about what answers they gave, where they think they're doing things well, and where they think they might want to improve. Judge, start?
Yeah, sure. So I guess like the project I'm thinking of is what I'm working on right now, which is provenance collection for large scale data processing pipelines. So in terms of what product qualities are really important, performance efficiency is huge, because if I ever want this to actually be used, I can't slow down the pipeline at all, because especially not in a way that scales by the data, because the data is going to be enormous. And so that's just critical. And then because it's provenance collection, it needs to be complete, then that's basically like functional stability and reliability. They are going to go hand in hand there. And then sort of less so is the maintainability and usability, but they're pretty close behind. Maybe usability a bit further down, because it's like an internal tool, not open source. So I was able to just put it less, because I know that like the people who are going to be using it are people who are also like actively developing this pipeline, and so I'm not as worried about making it completely like portable or anything. So
who wants to go next? Here, we'll go online.
I can talk about the project I was working on, which is it's like a runtime for virtual reality headsets. So it's runtime, and in that domain, performance is very important. Performance is very important. We want it to be like a research platform. So also like maintainability, so that other people can actually modify the code to do their research experiments, is very important. And like, what's the next thing?
So what do you feel you're doing well? If you get to like the reproducibility, what do you think your team's doing well already? And what do you think where you feel you could improve?
We have CI pipeline. We worked really hard to get it, which is really hard, because the thing depends on like some GPUs and some hardware. So we had to like make it all headless, and like we have to like headless OpenGL to run in GitHub CI container, which is non-trivial, but it's worth it, because we caught some errors and stuff, and that was good. And well, that's what we're doing well. But what we need to do better on is defining a software environment, because there's like a lot of it's like apt-get install stuff, and that's going to be different on different versions of Ubuntu, and that has already become a big problem. Like a 20.04 apt-get install will turn a different version of package than a 22.04. For example, you use online, it's not going to record. Yeah.
Gotcha. Who wants to go next?
I can speak maybe from a slightly different perspective.
Absolutely.
Because I'm not doing the work, but I'm contracted with a developer.
Oh, that's fine. That's perfect.
To develop the software for us. So I would say functional suitability is the #1 thing. Reliability, and then usability, maintainability are also all important. In terms of the things that would most help achieve reproducibility, I think like all of them are, but I would maybe highlight reliability and portability. is key for reproducibility.
Mhm.
Practices that I wish we could improve are testing. I think we don't do it nearly enough or nearly in a systematic way. And it's just this developer, I guess, and the way they do things. I don't know.
Yeah.
Portability. So, you know, we're already out there. I wanted community adoption to, I was hoping it would be higher than it is. And it's less than expected. And I think that there's some problems. It was also written in C++, and maybe that's a problem. I don't know. And then maintainability, because I think we need more people to be able to change and fix things and tweak things and not have to go back and rely on. Yeah.
Right. That makes sense. Who wants to go next here? We'll go on.
So I could go next. Yeah. So I'm working in an autonomous drive or open source autonomous drive software stack called AutoWare. And in it, what I'm doing is introducing software-defined best practices into that, which means a lot of different things. So I'm not focused on functionality, currently not focused on performance, these other aspects. So it's usability, reliability, and portability. So you develop in a cloud native environment, but you want to deploy at a physical, like NVIDIA Orin device or a Raspberry Pi, or depending on what part of the software stack you want to deploy on it, and be able to do that. One of the things I've done is just separate configuration from code. Because otherwise, if you have those interleaved, you don't have a single source of truth. How you configure your different nodes, then you don't know what's actually happening. And then there's no way to ensure that these parameters you input actually follow the range which it should. Like, for example, division by 0. You might not intend to set a parameter to 0. It might happen. So there's different ways to catch that. And one way is to do it with a JSON schema, for example.
Right.
So it's like not really changing anything, just making it more usable and more reliable. And I met a lot of resistance because people are like, I know how to do this. Wait.
You have
You know how to do it for this other node? No. Okay, well, there we go.
Yeah, there you go. There you go.
Do you ever have to like so you said that like certain like performance is not like a #1 thing. Do you ever have to like defend yourself against people who want performance to be the #1 thing?
So what I say is like, it's good that we're working on different things. So I'm not decreasing the performance. I'm just making it more. So if you know the system perfectly, there are 200 ROS nodes with at least 15 parameters each. And then you have, it's like thousands of parameters. And with thousands of parameters, you have billions of different configurations. But so yeah, I say that's great that you do that, and I'm doing this. So I don't take away from what they do, because that is important. And then you need to have a performance software stack, especially if you have hard real-time requirements.
So
yeah.
Gotcha. Just want to make sure. Oma?
Yeah.
Yeah.
Okay. Anyway, so for me, the main important thing were like performance, because we were building like dataset builder over software heritage, and you have to query such kind of graph, which can be like terabytes of data. You have to be efficient in the way you're doing it. But also like the usability should be one of the things we are targeting in order to make, for the moment it's a prototype, but the idea is to make it accessible to everyone to query such kind of archive in an easy way and create reproducible data sets. So,
Gotcha. Is there anything your team's doing well, you think, with reproducibility? Anything you want to change or different or improve?
Yeah, we would like to, I think we can try to make like a systematic reproducibility reviews, like giving artifacts to other team members to like code reviews, but like it should be like reproducibility review, starting from scratch and reproducing the experiments.
Gotcha. Makes sense. Sounds good. All right. So for people who are online, does anyone want to share what answers they gave with the rest of the class?
I will speak. Actually, my last time to program it was like 3 years ago, so I'm not.
Oh, that's fine. That's fine if not.
Okay.
I know. It's fine
And
if you
also,
don't.
I'm
Fine.
okay. I'm working also research on reproducibility, so I will be speak like with the reproducibility bias. So I will be focused for me in usability and the reliability. Because portability cannot be usually exist. I have this belief that the reproducibility cannot be guaranteed 100%. So usually, I think there is like a degree for reproducibility. So even we can reproduce, for example, this program, but we cannot like run it in another platform, but it's be reproducible. So portability for me, it's not usually important for the reproducibility, but usability and reliability, I think it's two factors has a major effect in terms of reproducibility.
Definitely, definitely. All right. Anyone else online want to share? All right.
So what we did here was trying to think a little bit about where each of your team's priorities are and what you're looking to achieve. And what we can do now is, if we'd like, we can go ahead and take a break, and then I can make sure everything's ready for the next session. What we're going to finish off with is on software process improvement. We have a toolkit that we're going to share with you, and we'll walk through some examples about how to realize process improvement, like how to improve, how to change things on a team, right? Step by step. How's that sound? Yeah, great. So why don't we break? Why don't we break for we're supposed to have a break for like 30 minutes. Maybe we start a little bit early if that's all right. If that's all right with everyone, we'll take a break here. You know, for about that long. Does that sound? Sounds good. Great.
Okay. Sorry, I was not really participating because I was on another meeting. Sorry.
Oh, you're fine. You're
But
fine.
it is, yeah, I see you having coffee. I just got out of the meeting, so.
Great.
But I will look at the recording and but you so are you guys gonna meet downstairs or?
We're gonna meet back here here within 30 minutes.
Okay.
Yeah.
Okay.
We'll take a break and then we're gonna finish off. We'll start back in 30 minutes and
Okay.
we'll finish off with the software process improvement component of our tutorial.
So like 3:15. Okay. That's good.
All right.
All right.
What did we, I'm sorry, I missed that.
So we're gonna take a break for 30 minutes. We'll start a little bit early, and then be back in 30 minutes to finish off the session. Though, you know, we can always start a little back a little bit earlier if people want. It's up to everyone else here.
We can do 15 minutes.
Sure. How about this? We'll do a 15-minute break.
Yeah, we should promote folks.
Yeah, for people on remote, we're gonna do a 15-minute break, fresh coffee, other things like that, and then we'll pick back up with the software process improvement stuff. How's that sound?
Great.
Awesome.
And United is, if there isn't enough coffee at United, is actually in the midst of brewing a fresh pot too. So it will come soon, but there's still all that pastry and stuff and yummies out there. So feel free to take that. Otherwise, I don't know what we're gonna do. I don't want it coming home with my piece.
I suppose I could take one.
Everybody can take, I was gonna say, everybody can take coffee bags.
Like those.
So this is all up on 599.
Yes, it is.
No, 506.
Okay.
506, sorry.
506. Yeah. Okay.
I got live again. I need to go see his paper. I'm getting text messages that I got papers accepted.
Yeah, you're like, yeah, I heard.
Now I have to go see it. They like us. They really like.
It's your Sally Fields moment.
Yeah, exactly. I don't get that.
Um,
Yeah.
you going to tonight? Did you?
Yeah. I'll be joining you.
Are you going back to your hotel, or are you going?
I don't know. I haven't planned that far
I
ahead.
mean, do you think you'll be there? I guess my big question is, how long do you think are you gonna go all the way to 5? I think, or?
No, we'll be done like at 4:30.
Okay. Cool.
Yeah, maybe earlier. We have a smaller crowd here.
Okay.
I these things take longer. This kind of material takes longer. If you have many different breakout groups,
Yeah.
and you have to go around each time.
Yeah.
But with a smaller group, we can get through the
Oh, cool.
content faster.
Great. No, I wasn't trying to push out. I was just trying to get an idea, and also for
Yeah.
your sake. Are you driving, or are you?
Oh, I took an Uber here because I was.
Oh, okay. So stick with us, and then I'll.
Yeah, stick with her.
And it's really close to your hotel,
Awesome.
so you can walk home after.
Well, thank you so much for joining us.
Yeah, thank you, and I apologize that I have to leave.
Yeah.
But this will be recorded, I could,
Yes.
because I'm interested
Oh,
in the toolkit.
Oh, yeah, for productivity and sustainability improvement planning. We have an entire toolkit, online resources, things people can use, and we do facilitate. And I also work as a facilitator, so we have people on our team. We do a lot of work with the Scale Computing Project, or have, right? Where we'd be brought on to do consulting and help them come up with software. Welcome. Thank you again for being guinea pigs for some of this course content, this tutorial content. So with that.
I just restarted.
Oh, great. So let me share. Yay. I got my paper reviews, one of which says, reviewer 2 raves, this paper is a valuable contribution to the field. Reviewer 3 says, it's great. Reviewer 4, let's see, succinct and actionable information.
All right, there you go.
So there we go. That makes my day. So which one else? Oh, perfect. All right. Well, welcome back. So what we're going to do now is we're going to be talking about software process improvement, how to precipitate, how to kind of engage with a team. Could be your team, could also be another team that you're working with, right? In terms of implementing software practices and processes that would help them, and ideally kind of gearing this towards reproducibility as the end objective. So what we explored in the first half of this was that there's a lot of different tools, practices, approaches that can aid reproducibility, right? By improving the software, the processes around the software, and that's all well and good, but the goal really should be is trying to figure out, okay, so what would I do on my own team? Or if a teammate came up and asked me and said, okay, so how do I get from A to B? I don't have any continuous integration testing. I don't have documentation. All of this seems like it's way too much, right? And how do we break that down into reasonable steps? And a lot of my work as a process improvement facilitator, as one of my many hats as a therapist, is to help teams figure out how they can realistically achieve these things, right? And that was what leads us to PSIP. So what PSIP is productivity and sustainability improvement planning. It is a lightweight toolkit for software process improvement that we developed for use with projects, particularly in the context of the US Exascale Computing Project. So working with many different projects across the ECP in many different domains of science and engineering in order to help them improve how they develop their software, right? And the idea is that PSIP is something, which we'll see, is meant to help you mitigate technical risk, right? Know where you're going, right? And how to manage that, how to identify topics for improvement on your project, and then how to create and use progress tracking cards, which are really the core of the PSIP method or toolkit, which was what we're going to explore today. But to set a little bit of context for why we care about process improvement and what that really means. So when we say process improvement, we mean techniques that assess, design, and realize effective development processes and practices, right? It's a topic that we're very passionate about, and it's one that's increasingly important for the scientific software community. So what we know right now, first, is that researchers are spending more and more time tied up in developing software, right? And using and developing software, to answer scientific questions. So there was a nice survey a couple years back where they asked researchers, like, are they spending more time, much more time than they were, years before in terms of developing software. And they also said, of course, we are all spending more time developing software. It was a replication study of another study that was 10 years prior, in which everyone answered exactly the same thing. And every time we replicate that, they feel like they're spending more time than they were last year on software, like in aggregate, right? So the idea is software is increasingly important. And second, we know that these projects are increasingly collaborative, multidisciplinary, multi-institutional. We are kind of at the end of an era where, you know, a small team working entirely in isolation can make, you know, real progress on these big challenges, right? Increasingly, we have to, you know, rely on one another, and that's kind of leading to a lot of changes in how we develop our software, leading to more community-driven software, open source software. There's kind of this push for more collective working around these things, right? And as a result, and because of the demand and the consequences of that software, greater than ever, right? There is a great deal of interest in improving software processes to be able to manage the scope, the scale, and the complexity, of that development, right? So that's also why we're seeing a lot of. Oh, thank you.
We're just looking at your chest.
Hi. Oh. Excuse me. What? Oh wow. So thank you, Jay.
That's
much better. So that's why we're seeing an interest in a lot of software engineering tools and techniques and processes, because we're all having to like develop software on GitHub and do all of these things with continuous integration and deployment and documentation and testing and everything else, right? So it's a great time. I think we're finally mending the divide, the chasm that long existed between the world of conventional software engineering and the world of scientific computing, where at least now we're having dialogue, and I like dialogue, right? So at the same time, what we have to be cognizant of is that software process improvement is something that can be really challenging. So there have been a lot of studies on success rates of software process improvement efforts in the wild. And the general consensus is that we see successes, but failures are often underreported. It's estimated that up to like 70% of software process improvement efforts fail to meet their targets, right? And by that we mean it didn't come together. They didn't get as far as they would have wanted. They didn't realize how much work it would be, right? What ends up happening is that adopting a new tool, a new technique, a new way of working, a process, anything really, that can be really disruptive. That's time you're spending on that is time you could have been spending gathering data, writing a paper, or doing anything else that would be advancing your career. You are spending on adopting and learning about how to do these software engineering things, right? And there's also this view, and I think it's a reasonable complaint, right? I think it's a reasonable critique, that a lot of software process improvement, so there's like CMMI, there's other industry standards that are out there for process improvement. I've got a whole Bible, it's this thick, CMMI on all the different things that they should have a process for requirements gathering, a process for design, a process for this and for that, and how to measure and grade a team, right? It's very prescriptive, it's very heavyweight. It's not very aligned with the needs of scientific software projects, right? It just isn't, right? It was never written with them in mind, right? So what we realized is that any productivity or sustainability improvement needs to be incremental, needs to be integrated into how they do their work day by day, right? Step by step. And of course, it has to be lightweight and iterative. Sort of the conclusion that our team on the PSIP team reached with this, right? So PSIP stands for Productivity and Sustainability Improvement Planning. It's a lightweight workflow, or that is a set of practices for software process improvement. It is set up in a way that can either be used on its own or alongside methodologies or favorite flavor of Agile or Kanban or what have you, right? And it's implemented through progress tracking cards, which is what we're going to describe, and we're going to do an interactive exercise with that, right? But at a high level, the goal of PSIP is to help teams figure out where they could make incremental improvements and how they do their work, right? Such that each step of the way, they're better off than they were before. So even if they stopped halfway, they are still better off than they were before. So it's not an all or nothing proposition, right? But that we can make realistic progress, right? Some examples of teams that we've worked with just used PSIP are quite varied, but just name a few. We worked with the HDF group. They do the HDF5 data storage, and we got them to agree on coding standards, something which they weren't able to reach a consensus on their own in over 20 years. and they attributed that to this, right? So we were able to make a breakthrough with their team on doing things with code standards, documentation of things like that. Another example, we've worked with people like universities like Darmstadt, with some of the projects there, figuring out how we can help academic projects in those academic, those contexts can improve their software processes. Understanding, of course, that they're not like some professional software shop, right? We're not asking you to do things like Google does them, right? Because what works for Google is probably not going to work for a scientific software team. But maybe there are things, there are practices, there are specific ways of working that could be helpful and they could be adapted to those contexts. There are other teams in the national lab space, a lot of different teams in ECP that we've worked with to great effect. So there's, we've had some really good successes in this kind of iterative step-by-step kind of process. So the overall framework is just a series of steps. So the PSIP framework provides an iterative, incremental, repeatable, and cyclic process for improvement planning. So software teams can work through all these steps on their own. We provide guides online, materials, self-assessment instruments, right? But we also offer facilitation. So I will sit down with a team, for example, and work through all this with them, right? And figure out where they're at, where they want to go, how they're going to get there. What I want to do now is just briefly walk you through the steps that are involved here. There's 7 of these. So first set of steps there on assessment is where we try to figure out where they're at. So the teams that we work with are comprised of world-class scientists and engineers. They are very adept at devising solutions to technical problems. That is not their challenge, right? The challenging part is often in identifying what matters to them and how the software goals are aligned with what matters, right? So when we facilitate an effort, we often start with a team meeting to summarize their practices, their processes, how do they deliver value, what are their scientific goals, their engineering goals, and then we can work backwards from that. So we talk about things like reproducibility, right, which is something we're going to focus on here. It's not an absolute, like we said in the start, it's not something that should be seen as an absolute good, but rather something where how reproducible, how important is it to you, right? To what extent? On how many platforms, or how many users? What's your real goal here, right? And how can we help you to achieve that goal and ensure that you're making progress towards it, right? So the end goal here is to identify, where there are certain barriers to achieving that quality, that efficiency, right? And we try to get teams to hone in on maybe 1 or 2. Don't overload them. Focus small. Start small. Name 1 thing, 2 things at most, right? That could be, we can improve within a week, a month, a quarter, possibly a year, right? Then the next part of it is tracking. So where's the team need to go? Where are they right now? That's where they construct a progress tracking card, which is what we're going to do the exercise for. Teams can either write one up from scratch, or we have a whole online catalog of cards that were built by teams we worked with, right, for a number of different things like documentation and testing. And then they can tailor those to their objectives. The next step then is integration. So, or as I like to call it, securing a commitment to action. So we kind of identify at a high level, and you'll see that the goal of a progress tracking card isn't to specify all the technical details of what the goal is, but really more to talk about states of practice, like where do they want to be as a team, right? And then from that, we can figure out the technical details. So setting up CI/CD pipeline, right? And then we can talk about the particulars of, okay, what CI/CD platform? Are you using GitHub Actions? Are you doing this kind of setup, right? Does it involve GPUs? Where are we getting the GPUs to run the test on GitHub Actions, right? Those are the technical details, right? And then what happens is they enact those changes. They will iterate on their plan. They periodically revisit their PTCs to assess their progress. And if there are unexpected setbacks or windfalls, the team, of course, can adjust their strategy as needed. So just to summarize the high level, so this is sort of an overview of the work that we do in software process improvement, is that when working with science engineering teams, we find that to make improvements, to make real lasting change, it needs to be incremental. There needs to be buy-in from the team. It needs to be integrated into their development process. And ideally, we want something that's lightweight and iterative. And that's why we developed PSIP as a toolkit for working with teams, right? And PSIP is implemented by progress tracking cards, right? So with that, are there any questions so far? I'll be happy to answer them before we go any further. All sound good so far? All right. Okay, so what I want to do now is it's all about progress tracking cards. That's the core of it. What does that really mean, right? What does that look like when teams do them, right? So a progress tracking card is relatively simple. It's meant to be a concise visual aid for recording and tracking your intended goals, deliverables, milestones, and so on. You create a progress tracking card or a PTC so that you can comprehensively compare, where you're at, where you're going. Are we actually moving towards this objective at all, right? And it's meant to help you keep track of that progress. And it's also something that you can share, as teams we work with often do. They share their PTCs with others when they're communicating to other teams about their goals. So it's a useful tool for kind of expressing intent, right? And it's made up of 5 components. So there's a title, right? What do they want to do? There's a target. What's the end outcome? They usually have a series of user stories. So as a blank, I want blank, so that blank. They all come to a consensus on why it is they want to do something, right? And then what we do is we try to get them to break it down where we have a set of states of practice. Usually is we're not doing documentation. And then there's a state of practice where we are routinely updating our mature documentation, right? But what we're really interested in is what does it look like at each step of the way, right? I worked with teams before where they said, okay, so we have a process in place to do a needs assessment to check to see if our documentation is up to date or not. So they have a set, so they're there, right? Then they have a review process they put in place, a review process for documentation. So every so often the documentation goes stale. Whenever you change the code, we want to make sure that when you put in a pull request that someone is looking at that documentation saying, does it need a change, right? And so each step of the way, they're doing that. And if they stopped halfway through, they are better off than they were before. Maybe they never reach this part. It's okay if they don't. People are imperfect. Projects, we have to be realistic, right? We can't I'm not going to promise the moon and the stars to them. 70% of process improvement efforts fail, right? And a lot of them fail because they bite off more than they can chew. And if there's not buy-in, then they, it all just kind of falls apart, right? So the idea, that's basically the idea. So the magic really is in how do people create them. So this is what normally happens when we do this. I sit down with the team. They'll get about this far with it. So it says they want X. Say we achieve X. We didn't have X. We have X now. Whatever it is, right? Could be documentation, could be testing, anything like that. And then they'll say, as a developer, I want X so that my project has more X-like quality to it. It's or what have you, right? And they get about here. They say we're here. It's where we want to be. And in the middle, they have absolutely no idea, right? Because in their mind, they just see the end state, right? This beautiful outcome, the promised land, right? No idea how to get there. Now, in social sciences, like in sociology, we call this articulation work. Articulation work is the work that makes work happen. Why are we here? What are we doing? Where are we going? And how are we going to get there, right? That actually is that's a form of labor, right? It takes work to figure that out, right? That's usually where they get stuck. And when they get stuck like that, there's a couple questions that come to mind, right? So did the team actually reach a consensus that this was actually important? This I have found to be a problem, right? Because sometimes one person on the team will say, we're going to do code reviews. And if no one else says we're going to do code reviews too, that's not happening. You need more than one person to do a review, right? It can't just be one person, right? So the whole team really needs to buy in or it's not going to happen, right? The next point is everyone in agreement about why this thing is important? They may want something for different reasons. And those reasons might actually conflict with each other, right? You know what I mean? Like sometimes they may want tests to make sure that it's reproducible. Others may want tests for performance. Others want tests for this or for that, right? And so we just say we all want testing, but when you dig down to it, there's a lot of different reasons why we want testing, right? And again, that ends up biting more than they can chew. They try to take on too much at once, and then it fizzles out, right? And then finally, and this usually is the most challenging part, what does achieving this in practice look like? What are intermediate states, right? Is there a way in which we can break this down where each step of the way, if we stop there, that's the litmus test. Are we better off, even if we never finish this, even if we abandon this? Are we still better off? If you're able to say yes to that, then you're on the right track, right? So, in general, what makes a good process improvement goal? There are kind of a couple characteristics here. One, ideally, a PTC should be collaborative and team-oriented. The whole team, like I said, needs to own the improvement. It's very easy to roll out a new tool, a new method, new anything, but if there's not a commitment to using it or doing it or keeping maintaining it, eventually it falls into disrepair. Maybe there's one person who cares about it, and when that person leaves the team, whatever they were doing it ends, right? It's also a commitment to keeping it going, right, through policies. So I often call this process decay. So every time I go to the dentist, I'm told that I'm not flossing my teeth enough, right? Every single time, without fail. And then for a couple months, I'm really good about it. I floss my teeth, right? But over time, it weakens my commitment to that process. And when the next time I come to the dentist, they say, you're not flossing your teeth enough, and the process starts anew, right? And if you want to avoid that, there really does need to be commitment, right? So the next part of it is something that can be measurable and specific. Think like artifacts, think like a process. We are producing documentation. We have plans to review the documentation, right? That it's not just you're going to write it once and it's done. Like documentation is a lifelong effort, right? You can't just write it once unless the software just stops changing it then and there, right? But usually for the stuff we work on, it doesn't, right? It keeps going, keeps changing, right? And the final part of it is really needs to be something realistic, right? The reality is that the teams that we work with, they have limited time, they have limited budget, they have a lot of things to worry about, right? And we try to figure out how to fit in activities that will help them realize their goals, like decrease their time to science, increase the reproducibility of their codes, make it easier for them to share their codes or to modify them, right? And then ideally that should be aligned with their objectives, right? All these changes really need to align with their bottom line. Go ahead.
So is this basically embedded in their issues?
Can be, yeah. So different teams. So what we do, some teams have literally printed this out, piece of paper, and then looked at it every time they get in the meeting room. Other teams, they put it in their issue tracker or Jira or what have you. We support, it can be done in any number of ways, whatever fits the team's preferences, right? And the idea, though,
And like GitHub issues and discussions.
Yes.
Or there is really good too.
Yes, and as a facilitator, most of my work is I get them to admit that they have a problem, that they need help, and then or that they need change, and then we come up with a plan. And then what I do, if I'm facilitating it, I just go to their stand-ups periodically, and I'm not pressuring them to do anything. I just ask for what the progress is on that issue, right? I'm just there as a neutral third party who's interested in them developing continuous integration testing. And if there's any roadblocks, I'm happy to talk about it, right? We sit down and we kind of think through, okay, so maybe GitHub Actions isn't going to work because GitHub Actions is limited to 6 hours. We want to do 10 hours of testing for some of our nightly testing, right? So we need to figure out how we're going to do that, right? So I kind of help walk them through that kind of thing, answer technical questions, but most of it is them doing it themselves and I'm just beating the drum, right? That's kind of how this works. So yeah, other questions on this? All right, so we have a relatively small group here. There's a couple different ways in which I've done this exercise before. I think what we can do for this exercise, let's see. So what we're going to do now, I'm going to stop sharing. I'm going to share screen here. 1 second. I'd like to do an interactive exercise with y'all. And I know that we're all not just on one team. Normally what happens is everyone's on the same team. But I have here is a template. And we've talked about a number of different practices and processes, and I don't know what we want to focus on, but I think it would be good for us to try to walk through this process, walk through the process of developing one of these, because once you've done that, I think it's fairly clear that you do this on your own, right? I'm trying to think if we want to pick a particular topic. There was a couple things that came up, like code reviews came up, testing was another one, and we can look at this from a reproducibility angle and walk through the adoption of some of these practices. How's that sound? Fantastic. So any preferences? Or what we want to focus on? Anything if only has a topic that they really want to focus on? We can focus on that.
Experiment automation.
Experiment automation. Okay, I like it. Okay, so Great, we're already partway done. All right, what is the goal here? Tell me a little bit about it.
Goal is that you can run a script on some infrastructure and make very little assumption about infrastructure. All you need is some reservation, and then you can rerun the experiment, you know, which includes like uploading the data, you know, instantiating the resources, you know, getting all the dependencies installed for the experiment, running the experiment, running the analysis, and analysis. I mean, there's a lot of things that can be in analysis, right? It could be validating an existing experiment from a different paper, and you can sort of part of the analysis is whether you actually confirm the hypotheses or not. And,
so this is big. See, I'm hearing a lot of fun things here. Why do we care? Like, I'm sensing there's actually multiple reasons why we want this, right? Can anyone name some? So we're going to phrase this as a user story. So as a blank, I want blank, so that blank. You mentioned reproducing a paper, for example. Who would be doing this? Why is it important to you?
Right. So there are like three groups, right? One is the student who wrote the paper, because there's the paper has been submitted and now there's some feedback and it needs to rerun the experiments with incorporate the feedback. And so I want to, you know, I want to be able to do this and not figure out what I did for 3 months ago, right? So like just do it on my own. The second person is the reproducibility artifact reviewer, because you nominated a reproducibility artifact, right? You nominated yourself as for like a batch or multiple batches. The third one is the instructor. This is a lead, right? Or let's say the third one is the other student in a different research lab who wants to use the reproducibility artifact as a baseline for a experiment to improve things. And then the fourth one is an instructor in a classroom who wants to, you know, wants to basically use the experiment to explain things, or want to basically get the students to reproduce the experiment.
Gotcha. Okay. So I'm sensing a couple here. Okay, so as a reproducibility reviewer, I want, let's see, to easily rerun people's results and see them with my own eyes. Yeah.
Yeah. It's sort of a personal productivity tool. So what you see here, and this is what happens when I'm working with a team, right, as a facilitator, is that there's always multiple points of view on anything important, right? In this case, with the experimental automation, there's many different stakeholders who would be affected by this, right? And they apply, of course, different quality aspects to it as well. If we're talking about other people using it, then usability is very important. If we talk about wanting to be able to extend this experimental automation in the future, that's a maintainability question, right? If we want to be able to do this in a way that's like, you know, efficient, that's a performance question, right? So you can see how there's all these different perspectives, and we need to be careful about what we want to focus on, right? Because if you just say this from the outset, and we have like 10 different perspectives, and we get pulled in 10 different directions on this thing, we don't have a clear plan, it usually fails. So if we want to achieve this, we have to think carefully. So as researchers in another lab, I want to reuse other people's experiments so that I can build upon their work. Okay, how's that sound? Sounds good to everyone so far? Okay, so for you may have a project in mind. What's a good start? What's the starting state here? Let's just say, let's speak hypothetically here. Like, let's imagine we're this project, right? And also this experiment automation, right?
Shell script.
Yeah. Okay, we have.
A monolithic shell script.
Manually.
Actually, no. The starting point is no shell script. Nothing. Just manual. Maybe I have a little cheat sheet that just reminds me of the command lines that I have to type into.
Yeah, you have your history.
Yeah, the
command
history.
lines. Yeah.
So not even shell script.
Yeah. You manually run
Something I
everything.
cannot share, essentially.
All right, so we manually run everything and document.
Or one form of documentation.
Okay, so there's a couple different things here. I'm sensing many different directions we can go in, right? So, okay, what is the desired state of practice, the end goal? What is the dream here? Workflow. We have in. Okay, so the end of it is that we actually have these tools and processes in place to maintain something that is end to end, that's going to continue working. So we have not only do we have this automation system, we are committed to it. We are committed to maintaining it. We are committed to using it, right? Now the real question is what happens in the middle, right? And each of these, what we're going to look at is how do we phrase this in a way that even if we stop there, we'd still be better off. So what comes next, do we think?
Scripts. Yeah, step one should be like basic scripts. Automation at least, and it's shareable at least. But in some cases, it might be like a README. Actually, it's not really automated.
Yeah. And document it so we can share them. We always break this down to further layers and gradations if we want. We'll start at this level, right? Okay, so what happens then?
This might be one thing I might be biased because I use this. I think there's one person here who might agree with me, and maybe it's part of the first one, but setting up the configuration system so that when you're running these scripts, you just have like something you can change to like run the experiment instead of the experiment itself.
Okay, so that right there, and that right there is something that in and of itself could also just be defined as its own progress tracking card. And maybe if we didn't have that already, right? We'd have to start with that. Right? We wouldn't want to put this in place until we had a configuration system.
It could be like the configuration like for the shell scripts or something.
Yeah.
So that it doesn't have to go too deep.
Okay. Assume that we have some way of doing builds and installs. Let's just assume we have that, because that would be a separate thing on its own, right? I'm going to assume for now that we have that, and if we don't, we'll build it. What comes next? Are we thinking about this in terms of an experiment automation framework that we'd get off the shelf or use someone else's, or is this something that we build ourselves?
If you don't have to build it, don't build it.
Yeah.
All right. So that right there implies that there's some activity, a process or something that's being put in place, right? In this case, some kind of needs assessment is going to happen, right? We need to dedicate some time to figuring out, can we reuse someone else's software? Because we shouldn't build something we don't have to, right? That'd be foolish.
So I have a question.
Yeah.
It feels like the outcome of that one, number 2,
yeah,
is going to affect everything else.
Yes.
So do you now start recurring and then make a whole new card for number 2 that you don't come back to this one until you finish 2?
So part of this, I think I'm sensing something here. So normally what I would do is say, if that's really, really important, we're actually gonna put 2, make this 3, 4, 5, etc. And 5. What normally I would do with a team is I would say they've defined certain shell scripts that run. Query control. I would probably phrase this a little differently, but something like we have processes in place to maintain them, right? And that can be broken down into as many gradations as you like. But the main thing there is for any of this to work, this automation system to work, it's going to require that you have a strong foundation to build upon, right? Mm-hmm. And what I would do normally there is if you didn't have these things already, that could easily be its own progress tracking card. But if we're starting with those things, then I think the first step would be that needs assessment, right? But assuming we don't have that right there is something that probably, and this is where I try to prevent teams from biting off more than they can chew, right? Because an experiment automation framework is a big target, right? We just identified multiple independent things that can be, build configurations, right? Managing that, scripts for running the codes that we can maintain, that we have under version control, that are documented, right? Each of those could easily be a progress tracking card into themselves, right? So, but assuming we have that, I think we would start with the needs assessment, right? But assuming we have, let's just roll with this a little bit longer. Okay, so we have an assessment. What happens if we decide if we decide to buy? Do we need to learn this other system and integrate it, right? I think learning the system is going to be an effort in of itself. We need to nominate certain people who are going to be responsible, at least 2 deep, for knowing how the system works, right? Not just 1, at least 2. Decide to buy. One way I wish to do that is to develop documentation, right? That would say, okay, this is how you integrate with our code, right? So if I get hit by a bus tomorrow, you know how this works, because otherwise, if a person gets hit by a bus, or wins the lottery, retires, what have you, no one's going to know how to run the system, and all of that work really, it's going to fall apart. No one's going to be using the automation experiment system anymore, right? They'll just stop. So there has to be a process in place for how do we do this, and how to use this on. Yeah, go ahead.
Can I ask a meta question? So this is, I totally see that this is extremely useful, right? Because you get sort of, not only are you doing this articulation work,
yes,
but you do it in a group. That means there's a common understanding on how to proceed.
Yes, correct.
But then there's also the fact that this is just a plan.
Yes, absolutely.
And so what happens if you now run into you miss things, step 1 of the process, you thought you actually had that, but then you discover No, actually.
Yeah.
It's not there yet because
Oh, yeah.
Step two.
This happens. And that's when you can always revisit the progress tracking card, right? But the real goal of the progress tracking card, I don't want to see any specific mention of a tool or a, like, we implement 100% of this or we do that. More like it should be abstract enough to survive minor technical changes, setbacks, and unknowns, right? Like, once you have the card, then we say, okay, what do we need for shell scripts? What does that look like? What does the documentation look like? All the details, right? But I want to make sure none of that gets mentioned here, because every time we work
Separate from the implementation.
separate, totally separate. Because if you start off with that, you'll get mired in all of the technical details. Because every time I do this with a team, they're very technical. They always are very technically competent, and they'll leap right to the solution, right? And then the next 60 minutes are spent on this, and they still don't know anything about what's going to come next, right? That happens so easily because we just naturally want to get it right to work, right? We want to get right to work, but you're missing the forest for the trees, right? So the idea of working through this, like with a progress tracking card, is to try to draw out all of these assumptions, the concerns we may have about the long-term sustainability of this tool, this solution, this practice, right? Because at each point of this, the goal here really is there's a process in place. There are things around it. It's not just the tool, because it's very easy to say we're gonna buy this tool, or we're gonna get it from GitHub and download it and put it into our code base and we start using it and it's great. But if it turns out to be more trouble than it's worth, or it's difficult to get people to learn it, or if we don't have good plans in place around it, it just tends to not work. I mean, like, I've seen this over and over. I've worked with teams where it didn't succeed. And it was never for a technical reason. It was never that the automation framework just didn't work or couldn't meet their needs. It was that they eventually just abandoned the process of using it, right? Because that was the thing that they really needed to work on, right? So yeah, that's good. So that right there should give you some idea about how this process works when we do process improvement. And you'll see how, that's it requires a holistic view of the different stakeholders involved, right? Because different people will want it for different reasons. It requires a view on the processes and the practices around the thing we're talking about, not just the automation framework, but everything that goes into using it, right? Is what we really care about, right? And it's about resisting the urge to leap to the technical solutions and the details that aren't really necessary for to capture the whole journey that we really need to focus on. That's the articulation work, really. So yeah. Yeah.
How do you manage? Do you have like just new versions of cards?
Yeah.
And then
yeah, sure. Yeah.
And then also wondering what that the lightweightness, is that because you don't require dates and times or anything, like any kind of schedule? You just
correct. That's determined later. Like, we determine that later, and then we kind of work backwards from that. So, like, when it came to the I can also show you some specific examples, like with the HDF5 group, all the different teams we worked with, where they created a card, right? We have, this is an example of catalog. Oh. So these are all examples of cards where we worked with a team and they created a plan for improvement and we worked through it with them, right? So this is example. This is what the HDF5 group did, for example. So they did these coding standards. They realized that the developers have reasons for wanting code standards, like the main project people, as well as the community contributors, right? So it's about consensus building with those contributors, right? So part of that was just reaching a consensus. Then the question is, okay, we have a coding standard. We can't just convert our whole code base overnight. But at the very least, we can say new code coming in. When we do code reviews, we will make sure that they are compliant with the standard, right? And once we've done this a number of times, we are going to have a feedback session and we are going to say, is this working for us, right? Then if that is successful, assuming it is successful. Then the question is, we need a plan. What does a plan look like for refactoring our existing code base to bring it in compliance with this new standard, right? And then finally, what they ended up doing was they set their long-term goal with that. They added in another step, which was we need tool support that will automatically convert people's code to bring it in compliance, like a PEP8 standard, that kind of thing, for their languages of interest. Because contributors may or may not be intimately familiar with all the inner workings of that standard and what the rules are. But if you have a tool in place, they don't have to worry about that. They just contribute their code, you refactor it so that it automatically refactors it so that's in line with the standard, right? So when they did that, they gave us some examples here. So for step one, they came up with a whole list of technical details, right? For how they were going to reach that, right? And there are many, many examples of this. And what ends up happening is that every single card tends to be unique for a particular team, right? That's why it's a little bit different from like a CMMI-like process. I also have my CMMI Bible I can teach from, but all of those tend to be very explicit and already like predefined. Like you are going to have a requirements gathering process. You are going to engage with your customers. Okay, I don't have customers, I'm my own developer. Okay, you're going to like have a stakeholder meeting on your sales or whatever. Well, we don't have sales, right? So what you end up finding is that like things that were built for conventional industry don't necessarily seem to fit, and things that work for one team may or may not work for another, right? So that's why we do this. That's why we have this approach. But yeah, so, and the end goal here, and we'll wrap this part up here in just a moment. When we're thinking about things like reproducibility, right? Big, scary challenge. When we talk about reproducibility, when I talk about that with a team, there is so much fear in the room. You know, like I said earlier, fear of paper retractions, fear of being wrong, fear of having to go back and redo everything, right? And trying to move past that into a healthier state of how do we manage this, right? How do we practically manage this day to day and know that our code isn't misleading us or like diverging from the behaviors that we want, right? And that's why we want to do this. And that's what we're trying to encourage here, is to approach these problems in a structured way. The things we have control over. We have control over how we do our development. We have control over the qualities of our software that we want to focus on in our implementation, right? But yeah, the other questions or comments?
On this section or the whole?
Well, on the section, then we'll talk more broadly. All right. So what we've seen here is sort of a sampler of course material that we've been busy developing. We're going to have to do this tutorial again for an even bigger conference, and more after that, and we'll probably have to do this on our own home institution. A lot of people are going to want a tutorial like this. And so what I'd like to do now really is get feedback on the content and where we're going with it, and what we can develop, because we can develop more materials geared towards reproducibility, of course, give more examples of that, right? But I'd love to get your thoughts, comments, any feedback you may have.
Yeah, I think this is, I mean, I didn't see, unfortunately, the full part, the first part, but this part I really liked. I think the thing that I needed to sort of translate that into something to sort of, I was constantly telling myself, why does this work? Or why would this work, right?
Yeah.
And this is for me always, so there are so many formal ways in software engineering, right? Where you do this and then you're supposed to do that, and then
yes,
and you can sort of easily get lost into all that overhead, right? I mean, scheduling is the same way, right? You can just completely go nuts with your scheduling and planning and prioritization, and, right? And it's sort of like this really. So for busy software engineers or anybody who's busy, there's like this weird balance that we have to figure out constantly, is this really, am I too lazy to try something new, and it's scary, and I probably would get more productive, but it also means it's more stressful because I need to sort of let go of my own old ways to do it. So it's like this investment.
Yeah.
But I'm not sure what I'm going to get out of it, right? And so I'm constantly like to have sort of like, when I go into something like what you're proposing here, I want to have a pretty plausible way of assessing whether this would be worth it.
So,
right? And then just to sort of like close this out, and for me, the convincing part was, you know, I think I would stress more why this works, right? What do you, why did you see teams succeed with this? And why this is sort of the most likely thing to achieve that. Yeah, that's what I'm actually looking for, right? Is I don't want any framework. I want a framework that actually goes to the core of the problem.
Yes.
And at the same time is also the minimal one.
Yes. I think the main thing and the reason why any of this works ultimately is due to consensus building and team buy-in, right? So we were working with a team, and we kind of did this independent assessment. We have online self-assessment tools we haven't gone into, but where they went through and they kind of self-assessed their project, where they felt they had strengths or weaknesses. And all of the developers were concerned about the fact that they were still using SVN and not Git. It was all SVN trunk-based development, and it was so painful for all of the developers. But no one wanted to admit that to the senior developers. Everyone just kind of was hush-hush about it, right? Until we set them all in the room together. And then they all revealed their answers at the same time. And the senior developers are like, no one told us. And no one told us this was the problem. I was like, is this painful? I was like, yes, we spent hours and hours like, oh my God, lock down the trunk. Someone has screwed up this branch. I don't know how to, this development scheme. We are constantly stumbling over each other. And it really is hurting us. And all our other projects use Git, so we already know how to do that. And that was the thing. That was the thing where they all came together and had that coming to Jesus moment, right? Was what really enabled them to succeed. Because oftentimes it just goes unmentioned. I mean, people don't want to rock the boat. They don't want to complain, you know? So there has to be a pain point, though. There has to be something that they're worried about, right? And I think reproducibility is a really good conversation starter. Because like I said, there just seems to be so much fear around it. And they're always concerned that they're not good enough. And I was telling them earlier, like when I ask a team why their software isn't more portable, they'll say they can't really support Windows right now. They can support these different OSs, but not that yet. But if you ask them, why isn't your software more reproducible? Well, you've insulted their academic integrity, right? And I want to move past that. I want to move past that healthy attitude, right? You know, and I think that's a way of doing it, is to say, what are we doing? Is there anything we could be doing that would make us less worried about this problem and deal with it and face this fear head on that our code isn't reproducible, right?
And I think something too is to cultivate a culture where you have like continuous learning, continuous improvement, 20% more or less allocated, where you don't actually work on what you're supposed to be working on, but just improving everything around it. And then you'll learn better tools and become more efficient at your actual job. So I think, because a lot of pushback on this is I don't have time.
Absolutely.
But if you already have the time allocated for tasks like this, which will benefit, and anyone's like, if you become 5% more efficient at what you do every year, over a 20-year period, you'll be twice as productive or more. So.
Yeah, that is part of it. So like we as professionals can rationally choose to do things inefficiently, right? Because there's overhead involved and we have deadlines now. Like the improvement is something off in the future. My paper deadline is tomorrow, right? So right there, or my milestone, my deliverable, my whatever to my funders, right? That's a hard deadline. Yeah. So the idea is to create that space where you can spend time. And it's worth it. You can convince yourself that it's worth spending time on. Yeah. Right.
If you're in for it's like, it's not a sprint, right?
Right. It's not a sprint.
Yeah.
Yeah. You're in this for the long haul.
Yeah.
Right. Exactly. Other thoughts, comments on the whole thing?
So I think that this is actually a fantastic opportunity to not only provide frameworks for improvements, but to actually also sneak in actual strategies for improvement
Yes.
as examples.
Yes, absolutely.
And so this is for me, I think that it's like one of those rare moments where people sit in the room and actually even have time to talk about it, because otherwise they don't.
Yeah.
Right? They just have to get the day job done, but then
Yeah.
here's like a tutorial, and they get to actually exchange experiences.
Absolutely.
Yeah.
That's what we're doing right now. So we have our case study partners, and they're actually already, a lot of them are already successful. Like they have found things that help them with reproducibility. And we're working backwards and saying, how would you teach someone else, and turning that into a card. So, and like, for example, the team where we're working, one of the teams we're working with, when they do code reviews, they started off with just like one developer, another developer looking at it, but they also had all these domain experts who would come in and sign off on solutions and everything. And so for really critical things that are going to affect the performance or the behavior of the code base, they actually have multiple rounds of review, right? Where you have people from different backgrounds. They're saying, well, yeah, but does this really make sense with the physics or what we're aiming to achieve, right? One is it reproducible? That's good, but also are the numbers good, meaningful, right?
Right.
So they have technique, they have ways of working. Or for example, another team, every time they do continuous integration testing, so they implemented that. But they said, how do we tailor this to better make sure that we're meeting our reproducibility targets? They said every time a new paper comes out in this field, this domain, we're going to try to construct a test case that represents that paper and tries to replicate their results with using our tool, right, as closely as possible. And then when our code base evolves, we can go back and check all these other papers, right? All these other experiments other people have done, and we are able to build upon them. We head now.
Yeah, thanks so much, everyone.
No problem. Thank you so much for joining us. But yeah, it's another, So we are gathering up a lot of really good examples like that, right? And we believe there's more out there. I believe that there are teams out there that have found solutions that work for them, but they're not widely disseminated, right?
That's what we're trying to change at this conference.
Oh, exactly. That's what I want to do, right? That's kind of my objective, like with this as well.
That's. I think there are a ton of really good practice, and the other thing is also you get these accidental things, right? So, for instance, we've been really driven towards, like, ever since there's Cloud Lab or there's Community Cloud, or these, or even like the commercial cloud providers, right? The allocation is temporary, and so especially Cloud Lab that was a huge mind change for students, because they couldn't just set things up and then just let it sit there, walk away, and then just assume that it's like that
forever,
forever, which of course wasn't. First of all, it wasn't, because even if there would be, like, the state would preserve, right? Students would over time change things. And then 3 months later, when they were supposed to reproduce the graphs from 3 months ago, it wasn't possible to do, because they kind of, like, bit by bit.
Yeah, right. It's all changed little by little. And now it's like, what did I build? What did I do? I don't even remember anymore.
But now with temporary resources, you're forced to reestablish essentially your experiment every time.
Right.
And you get really tired very quickly.
Yes.
And so with the automation, it becomes much more reproducible.
Yes, and this also gets back to what we discussed earlier before you joined us. We looked at, like, software quality aspects and how that related to reproducibility, right? So a lot of things like reproducibility, big and scary, but installability, something we can manage, right? Now, if we can make it easy to deploy it in this clouded environment, right? Not only is the code better off, but we know that we're installing the software we think we're installing the way we're doing it, right? And we don't have to count on remembering anything, right? So that is something we can actually build into our software that helps the reproducibility, right? Exactly. So we were looking at different ways earlier on about that, and looking at examples of software quality trade-offs and priorities and that kind of thing.
Oh, sweet. Yeah, go ahead.
I did want to say I really, really, really thought it was good how much throughout this whole workshop you emphasized that there are limits to reproducibility, and you need to be like you don't have to be doing this for, like, necessarily decades or for every operating system. Like you have to, like, sit down and think about what it is that you guys want. And I have a follow-up on that, but I'm looking at a piece of note that I wrote just now, so I'm actually going to tangent real quick.
Sure.
At the very beginning, you mentioned that the ACM reproducibility definition and then the NACM rep definition, they are the same now.
Oh, good. They're actually being, okay, great.
Yeah, so the ACM switched.
Yeah.
There's still the old page So when you Google it, you got to make sure, because there's one that shows up that says like
Not reproducible. The search is not reproducible anymore.
Yeah.
Yeah.
But yeah, they should be the same. Okay.
Okay, good.
Back. So there's I'm probably coming at this from a slightly unique perspective compared to the people you work with.
Yeah.
On maybe just defining the type of software you're talking about.
Mhm. Yeah. Oh, absolutely.
So I'm coming from the whole experience of like I replicated like the Trisnovic
Yes.
study, and so when I think about science code, I'm
Yes.
thinking about those.
I should be okay. I probably didn't give my definition up front. When I say scientific software, I mean any software that helps answer a scientific question. So that is anything from an application code for something like astrophysics, to an IO library, to a visualization tool, to anything that is involved in that whole software stack, the whole process of discovery, all of it, right? So all of that is included in my definition, like any kind of tooling that is anywhere along that chain of events, from concept to innovation, right?
So then I think that even more so, it's important that you mention the like limits of reproducibility, because I actually think for code like that, I mean, clearly I think that reproducibility of that code's important because I published a paper on it.
Yeah.
But the like defining how reproducible it needs to be is going to be very different for that code compared to the library that astrophysicists
for sure
are constantly using for multiple publications. And even so much to go so far as to say, like, you probably want version control for that, but a lot of these other tools for like at that far end of the spectrum, you probably don't need unit tests.
Right.
You probably, I mean, would it help?
Would it help?
100%.
But do you really need
Are they going to do it? No. Even if you tell them they have to do it, they're going to be like, I'm just not going to publish here. If I have to write unit tests for this, like,
oh, absolutely.
CSV parser.
Or 6 million line code already.
I think and there's an interesting Philip Guo, who is at one of the UC schools, not this one, I think San Diego, I'm pretty sure. In his dissertation talked about research programming, and I would say, which is more like what I'm talking about.
Oh yeah.
And so I think for those ones, it's a weird, they fit into a weird spot, and I don't know. Yeah, because like you don't really want like continuous integration or unit tests or anything.
Oh but that's also why we talk about this when we talk about with teams. It's about like tiered approaches to software quality, right? And tiered approaches to practices. Is I am not expecting every team to do the same things. I'm not expecting every team to end up in the same place, right, with their code. I mean, sometimes it's a small script and it's going to stay that way, right? Or what have you. But that's fine.
Yeah.
Right. But it's more about being intentional, that we know why we're doing what we're doing, and we have a good justification for why we're doing it, right?
Yeah.
You don't want to be in a position, and the reason why we bring this up, the reason why we have the tiered software quality practices, all of that, is what we would see in our center is you'd have a code that was very small, very reasonable. They publish in papers, they get very popular. Everyone wants to see the code, share the code. Everyone wants to add to the code. It becomes this gargantuan behemoth. Is completely unmanageable, because when it was designed to be small.
Yeah.
They didn't think about any of practices or the code itself. And now it's just like unmaintainable. And I've seen projects that are now in production or that are like used for very critical. I mean, like, national security applications that are a little bit kludgy now and show their age. And it's very painful to work with. And that's what happens.
I think that particular story is exactly what I think is really interesting. Is you might start with just like a single Python script that was really just meant to read some input data and then produce some plot, and then over time you can trace its provenance.
Yeah.
You're getting like a library that people are reusing again and again. And at what point do you go from, hey, this is just some research programming, I don't really care that much about like unit tests or anything. Eventually you're going to need that, and figuring out where in that like transition period all that happens, I think is really interesting.
It's still something that's not really settled in the literature either. Right? We have there is relatively low data on research software, right, compared to say commercial software, right? And it's something I want this community to spend, develop more of that literature around it, so we have a better understanding of what we're even talking about. When do we need these things? What kind of reproducibility practices are appropriate for people at different stages or different kind of domains, right? We don't have a clear answer on that yet, right? But that's a really good point. Yeah, I think it kind of goes hand in hand with what kind of software we're talking about in the first place. There's some tension there. Definitely. Any other comments, feedback, things you like, didn't like, or think that we should focus more on?
How you presented this. It's
Oh, thank you. This is part of my, it's my day job. I, in addition to being a researcher, I was telling them I'm a therapist in my day job. So I sit down with teams and I say, so your code's like compiling, but how does that make you feel? Right? Until we get to the root of their socio-technical psychosocial complex. It's funny, my PhD was focused on formal verification, theorem proving, Boolean satisfiability, that kind of thing, right? But what I realized was I could build a perfect tool. Doesn't matter if no one's going to use it. And to build things people are going to use, I have to understand them, how they work, what they really want. And over time, I became a human factors therapist for software people. That's kind of what I do now. Yeah. So great. Well, what I'll do is I can stop the recording. If there's no other comments, we can thank you, everyone. And hopefully for those of you who had to leave a little bit early, you got a taste of PSIP and what this whole process improvement effort looks like. And yeah, great. This is a good trial run. I have to do this again.